Our mechanism question on this exam looks at the mechanism for an addition to an aldehyde or ketone. And this one specifically is the alcohol addition. And this is an especially important reaction that you'll see again and again in biochemistry, because the formation of especially hemiacetals is something that's quite common with sugars. Now, in this case, we have a diol, so we're going to go all the way to the acetal, or in this case, because we're dealing with a ketone, all the way to the ketal. But it is overall the same basic reaction. Hopefully we know by now that under acidic conditions, the first step is almost always protonation of the carbonyl. And we will draw this entire mechanism with equilibrium arrows because this entire reaction is reversible. So we've made our protonated carbonyl. This makes the carbonyl makes the carbonyl a better electrophile. So now our alcohol, which is a fairly mediocre nucleophile, can attack. The lone pair from the alcohol attacks the activated carbonyl and moves the electrons up. To give us this intermediate. We then get a proton transfer from what was our nucleophile over to the OH group. That's going to help make it into a better leaving group. To get us to this new intermediate. Now, in a reaction like this, we may have just started by drawing out the product if we knew what it was. And this is a reaction that's familiar enough to us that we possibly could have done that. So now we need to get the other alcohol to attack. And it might be instinct at this point to have the other OH just add in, kick out the water, and then we formed our 5-membered ring. But we can't do that here. And the reason we can't do that is that would essentially be an SN2 reaction with a tertiary leaving group. So what we need instead is for this oxygen to add its lone pair and kick out the water. To give us a new intermediate. Now, this looks very similar to what we had over here. We have a carbonyl that has an extra group on the oxygen, which makes it a better electrophile. And that will now allow this oxygen to attack. It's able to at this point because it's an sp2 carbon, therefore not sterically hindered. That now gives us our 5-membered ring with one of the oxygens protonated, and we just need to lose the proton to get to our product.